Okay, everybody, so I'm going to go over a question from the homework and use that as a springboard to explain some other stuff. Okay, so somebody came up to me yesterday and said, I didn't know how to do this question without graphing it. It says, without graphing, as you can see right there, how can you just look at those numbers and tell if your parabola is going up or down? And I said, this is kind of cheating. You just have to imagine the graph. Like if you look at this and go, okay, X is going from left to right, and look what Y is doing. It's bigger, it's going down, it's going down, it's going down, it's going down, but aha, this is your aha moment right here. Aha, it's going back up again. So that would only be possible if the parabola was going down and then it turned around again. Because, hey, we hit -3, but then we hit -3 again. That's only possible if the parabola is shaped like this, which means A is positive. For the B one, it's negative, and then it's a little less negative, then it's positive, then it's even more positive, but then hold on, it goes back to 3. This point's 3, and this point's 3. That's only possible if the parabola is going down. So it says without graphing, but it's actually just kind of trying to trick you into imagining the graph. Without imagining what its graph looks like, you're probably not going to understand and get this question. But for this graph, definitely A is negative. Or, well, -1. I actually don't know that it's -1. It's negative something. Now, here's where I wanted to go with this question. Let me erase all the doodling I just did. And let's do something kind of fun with this. What if I told you we could actually find what equation it is that makes this? And we could do it using our grade 10 skills. See if you can spot the point where I switch over to grade 10 skills. First of all, this is also a nice little way to wrap up kind of the end of our discussion of the standard form. What is the standard form of a parabola? Well, it's y equals ax squared plus bx plus c. Yesterday in our lesson, we learned that there's a slightly more useful form where it tells you what the vertex is. But this is the form we're going to play with today. Maybe I was unfair to that formula by saying it's less useful than the vertex, because it's about to be real useful in a minute. I actually have a hard time imagining how I do what I'm about to do with this form. I'm going to find the equation of this parabola just from the points that they give me. Now here's the first one I'm going to put. I'm going to use this one. This one has a special name. It is, of course, when x is 0, you call that the Y-intercept. And oh yeah, we already know that the c value is the Y-intercept. So we know that whatever this equation is, I don't have to say c anymore. I can say -4. Well, that's the only one I know directly. I don't know what a and b is, but I can figure it out by just picking any other 2 points. How about I'll pick this point here, right next door. When x is -1, y is -3. So y is -3 when x is -1. I'm going to tidy that up. What's -1 when you square it? What happens when you times -1 by -1? You just get +1. So I don't have to write a 1. I know a means 1a, right? -1 times b, I could just call that -b. And then I'll rearrange this a bit. I'll move everything to one side that's a letter, and I'll keep the numbers on the other side. So I'll add 4 to both sides of the equation. There. Okay, but now I'm stuck. Do I know what a and b is right now? Well, no, I don't. I mean, they could be anything. All I know is that a minus b is 1. It could be 5 and 4, or 6 and 5, or a billion and a billion 1. I really have no idea what they are yet. You know what I need? Think back to grade 10. I need another equation. So why don't I just pick a different point? How about I'll pick this one? Y is -3 when x is +1. This isn't going to be a very different equation, but it's going to be a little bit different. Just because the b, oh, wait a minute. I said b and then I wrote the, just because this x is a 1 and not a -1. So now this is going to be the equation -3 equals 1a plus 1b. Rearrange that. Oh, don't forget the minus 4. I almost forgot the minus 4. Rearrange that, move the 4 to the other side, and I get a plus b is equal to 1. No, it's still, add 4 to both sides, it's still 1. Excuse me. Maybe I should put my microphone on here. I'm shouting. So, what do I do with those two equations? What did you learn how to do in grade 10? Do you remember something that your grade 10 teacher would have called a system of equations? Also known as two equations and two unknowns. I can take these two equations, oh there, that's better. I can take these two equations and I can just add them together. A minus b equals 1, a plus b equals 1. Add them together. What's negative b plus b? Nothing, they cancel. But a plus a is 2a, and 1 plus 1 is 2. A is 1. And then, now that I know that a is 1, I could plug a 1 in here, or I could plug a 1 in here. I'll plug it into this one. 1 plus b is equal to 1. No, b is equal to 0. So there we go. I know that the equation here, which I almost knew, I knew part of it, but now I know this part and this part as well. Y is equal to 1x squared plus 0x minus 4. And I don't think I'm going to bother writing 0x too often. What's 0 times anything? 0. So there it is. That's the quadratic. Oh, I don't know. That's supposed to be an equal sign. That's why. That's the quadratic that you get from those points. You can use your grade 10 skills and you can find it. Now, we don't actually make you do stuff like that in this course. That's a little more algebraic than this course has to be. So there must be a different way to do it. There is. There's a technology way. It's called a regression. So let's show you how to do a regression. If you've got Desmos handy, open up Desmos. And we're going to make the equation for this using points. So I'm going to switch my screen over here a little bit so that I can easily type in Desmos. And open up Desmos. And you're going to go to, let's see, I'm going to go to a graph I just made. There we go. There it is, open graph. There. So you are going to do this. You are going to open up, you're going to hit this plus sign. And when you open up the plus sign, it asks you, do you want an expression, do you want to make some notes, or do you want a table? Click on table. So open up Desmos and click table. And then it's going to give you a table. Hopefully it says x1, y1. And then you are going to type in those numbers. Those are the numbers that we just saw for x and y. The table button's on the plus sign, right? This little sign here, can you see where I'm pointing? And then open a table, and then type in those points. Now, TI users, you are going to do what we did back in stats. Go to stat, edit, and then put the x numbers in L1 and put the y numbers in L2. I'll pause the video for a minute while people enter their data. I haven't done attendance yet anyway. And then we'll get back and we'll finish this question. And we'll do the next one. And then we'll move on to new stuff. Okay, so I'll just pause the video while you enter some data. Okay, hopefully that was enough time for you to enter the data. If not, pause it again and finish entering. So you've entered this data, and chances are it made some dots for you. There's your dots. Now, how do I get my Desmos program to figure out what parabola equation hits those dots? Well, here's how it works. I'm going to just bring up a screen here. I already have the data for the next question in, so okay, I'm going to type here. So in number 2 here, I'm going to type in y1. Now why y1? Because I have a list of elements under y1. It'll even tell me, oh, you mean the list that has 6 things in it? Yes, I do, right there, 6 things. And then I don't hit equals. Do you know in math what the symbol for approximately equals is? Somebody with their hand is making a little wave. Do you know where that is in your keyboard? It's a tilde. On here, I don't even know where it is. It might be under functions. It's under the letters. There it is. Approximately. You have to go. So on the keypad, if you're using the keypad, you have to hit ABC, and then it's right near the bottom, tilde. If you're actually typing on a keyboard, it's under the escape key on the top left. But there it is. That's how you get to it on Desmos. Okay, now go back to the regular keyboard by hitting ABC again. Y1 is approximately. Now, what does a quadratic look like? Well, it looks like ax squared plus bx plus c. But you have to say which x's you want. You want the x1 numbers, because you could have multiple sets of data. The computer would like, well, which one do you want? So we hit A. I guess I have to actually go back and type the letter A. A x 1, it's not an equals, it's an approximately equals, it's a tilde, squared plus, go back to the letters, b x plus c. And then get the thing out of your way. Oh, I forgot the 1 on the x. That's the problem. ax1 plus bx1 plus c. And then it's going to do, this r squared here is called a squared regression. That capital R stands for the word regression. And that's a fancy way in math of saying it found you the parabola that comes as close as possible to hitting all of these points. And in fact, this one's perfect. It goes through all of those points. And now it tells you the A number, the B number, and the C number. It should. This little window should be there somewhere. Did you make sure you typed in x1 squared and bx1? It has to be a 1. Without these little ones, it doesn't work because it doesn't know what data to take. Okay, while people are fighting with that on Desmos, my TI user here, and anybody watching this video later who uses a TI, on the TI, you have these two lists, right? So you are going to go to Stat, Calc, and see right here, number 5, Quadratic Regression. So you're going to hit 5. Now, if you have a plus, there's like a menu where you can enter. I just have the regular TI, or if you have an 84 plus. I have an 83 plus, so I have to remember that I have to type in the quadratic regression of list 1, comma, list 2. So you type L1, L2. Then when you hit enter, it does the same thing that Desmos did. It tells you that the A value in this equation is 1, the B value is 0, and the C value is -4. Now, if you want to actually see the picture the way you can in Desmos, well, you'd have to make sure that you set your window so that you could see everything. Let's see, -10, 10 looks good. You'd have to turn stat plot on for L1, L2, and click on dots. Okay, that works. And then you'd have to graph the dots. So there's the dots. Then you'd have to go to your y list and type in the equation. So the equation is y equals 1, I'm not going to bother typing a 1, x squared. And then remember, b was 0, so I'm not going to bother typing plus 0x. You know, you can just say that's nothing. And then -4. And then this equation should stab through all your dots, just like it did here in Desmos. Isn't that lovely? There are trickier ways that you can actually move the equation without having to type it, but I don't want to get into that right now. That's pretty complicated. We might do that later. Okay. Wasn't that fun? Let's try it one more time. So I'm going to erase this guy. I'm going to get stat plot 1 off here. Take away the dots. There we go. So there, that takes away the dots. And then I'm going to get rid of this equation. And then I'm going to type in new data. So I'm going to turn this one off. I'm going to turn this one off. And now let's do the second one. So the second one is this data here. X is 0, 1, 2, 3, 4, 5, and Y is negative 13, negative 3, 3, 5, 3, negative 3. So once again, I'll pause the video. If you're a Desmos user, type another list with X and Y. And if you are using the TI, you can either erase the data that you already had in the TI, or you can do what I did and just put it in the next lists. I put it in L3 and L4. I just have to remember that that's where it is. Okay, so I'll pause the video and you can take a second and type in your data, whichever format, whichever technology you're using. Okay, hopefully that was enough time for you to get the data in. Okay, so graph these points, and that's definitely an upside down parabola. So, okay, how do we tell this thing, make me the equation that hits all those dots? We type y2. Now, for me, it's y2 because this is my second set of data. So y2, and you don't hit equals, you hit approximately equals, which is the tilde. And then you go a, x, and for me it's x2, right? Because this is my second set of data. If you erase the first data, then you go back to x1. Squared plus b, where's b on the keyboard? B x2 plus c, and there it is. A is negative 2, b is 12, and c is negative 13. So go back to the question, and you can say that for question B here, the equation is y equals, and that's how good my memory is. I've already forgotten what the A, B, and C were. It was negative 2, 12, and negative 13. So negative 2, 12, and negative 13. That's the equation that all of those points fit. It's actually perfect, isn't it? It goes through exactly all of them. And then one more time for the TI people. How do you do this with the TI? Okay, so with the TI, I'm going to say I would like to do a stat calc number 5, a quadratic regression, but be careful. This time I'm using list L3, comma, and L4. If you used L1 and L2, then you type in L1 and L2 here, but I used L3 and L4. Hit enter, and there it is. There is my equation, minus 2x squared plus 12x minus 13. And if I want to see that as a graph, I would have to go to stat plot, and I'd have to actually ask it to plot list for me L3 and L4, and that puts my dots on the screen. And then I have to graph the equation we just had, which was minus 2x squared plus 12x minus 13. And there you have it. Now, what use is all this stuff? Well, we kind of already had the conversation when we started this unit that every single object that is launched or thrown or flung in gravity will make a parabolic path. So if you're doing a physics experiment involving something that's flying through the air, you're going to get data that has to somehow fit a parabolic equation. But the actual amount of time and effort it would take for you to algebraically find the equation could be forever, especially these ones are nice. These ones actually work out so that the parabola goes exactly through the dots. What if there was human error when you were measuring the dots and you're off a little bit? Then you have to get the computer to get the closest possible parabola that hits all the dots. Doing that with pencil and paper would take forever. But a calculator, that's what calculators and computers are good at, doing lots of little calculations really fast, much faster than people could do them. So this tool called regression, where you find the closest possible parabolic equation to some data, is absolutely essential to the sciences. And it's not just physics. Chemists, biologists, just about every branch of science will hit some sort of system that turns out, aha, the equation that describes this data is going to be a quadratic. Okay, we got a question.
What are the x values in the equation? What do they represent?
The x values represent the dots, right? They represent all of the points. Well, because that's the way that this equation actually works. Remember that there's another way we could write the equation. We could write it like this, and then you'd only have one x, but it's being squared, right? And remember that if you have the equation like, let's say, for example, well, because then it would go the other way. Here, let's get this out of here for a sec. So if I have the equation y equals x squared, right? That is just every single possible point where x and y are being squared, right? So when x is 1, y is 1. When x is 2, y is 4. When x is 0.5, y is 0.25. Whatever. So x and y represent points. You could think of the equation and the graph as an infinite set of points connected together. Whatever x is, y is. But now, if I take this equation and I say, for example, minus 1 to it, now all of these points move down 1. So that's going to move down 1, that's going to move down 1, and that's going to move down 1. There, they're still there. But now take a look at what that equation looks like. Right? It looks like that. Now, one more trick, and this will really answer your question. What if I move the equation over 1? So let's go back to what these dots were before. 1, 4, and 0.25. There. What if I now do this and I shuffle it 1 unit to the right? Well, that means the x values have to move over 1 to the right. So this 1 becomes a 2, this 2 becomes a 3, and this 0.5 becomes a 1.5. There, I hit all the dots again. So, guy who asked the question, take a look at this equation. It has one x in it, right? Yeah. But what if I wanted that equation in standard form? If I want this equation in standard form, I have x squared minus 2x plus 1, because that's what you get when you take x minus 1 and times it by itself. So that's why the x happens twice. It's not a different equation. It's still just take all the x values, take 1 away from them, and square it. Then tell me what the y value is. Just like I did here. So the fact that there's two x's, x doesn't mean anything different. It's still just a relationship between input and output. It just happens to make this curve. Okay, so anyway, that's all I wanted to do with that question 6. I just wanted to play with it a little bit. So I'm going to end the video here. So this video, I'll title it, How to Do Regressions on Desmos and TI using number 6 of chapter 7, 7.1. So thanks for watching that.